Hello, my name is João Fabro, and I'm here today to present the paper NOPL, Notification-Oriented Programming Language, a new language, and its application to program a robotic soccer team. In our development team are also Leonardo Santos, Matheus Freitas, Adriano Ronszcka, and Simão from Federal University of Technology, Paraná, from Brazil. This paper then presents NOPL version 1.2 and its compiler. This language we developed and we implemented the complete program to control a team of robotic soccer players. This language implements the concepts proposed by the notification-oriented paradigm, or NOPL. That is an evolved mix that brings together concepts from both declarative and imperative programming paradigms. This version 1.2 improves over the prototypical version of the language and compiler that's version 1.0. This first version had some limitations which made difficult the development of complex applications that solve real problems. This new version 1.2 is then evaluated in the development of a complete control software for robot soccer matches using a simulator from the small size league RoboCup category. And we make a comparison between code developed in NOPL 1.0, NOPL 1.2, and a previously developed control system using object-oriented C++. Usual programming paradigms nowadays include the imperative or object-oriented languages and declarative, that are rule-based systems and also logical languages. NOPL is a different approach. It's a reactive approach based on a notification graph that only propagates notifications when it's actually needed. And it's a diverse approach to programming in software development, because in NOPL there are no loops or search as in fast engines of the declarative paradigm. NOPL, the first NOPL implementation were in form of frameworks over usual imperative language such as C++. Nowadays we have also these frameworks in Java and C# and other languages. But usually imperative programs have loops that continuously reevaluate variables that do not change their behavior, their states. So in this case we have several reevaluations of attributes that usually do not change their states. So why is NOPL different? Because a notification only occurs when something changes in any attribute or premise or condition. There are no loops, only rules. And that brings together classes and objects from the object-oriented imperative programming paradigm and rules from the declarative paradigms. So we have an element called FBA, fact-based element, that has its attributes and several methods. Basically, a class or object from the object-oriented imperative languages. But differently, we have rules that are notified when attributes change. Every time an attribute changes its value, it notifies every premise from every condition. Only when the premise changes at its value, it notifies the conditions, and the conditions notify the rules, and the rules notify actions that instigate the execution of methods. And inside methods, there are only calculations and execution, not specification or if statements. And execution of methods can change attributes and restart the notification process. Here is an example of a program in NOP. You have an instance of an FPA with its attributes and methods, and these attributes are connected to premises and premises are aggregated in conditions, and conditions notify rules that then execute instigate methods from the instance of the FPAs. Here is an example of syntax in NOPL. You define the FPAs, example robot, with its attributes and methods, and then you write rules that relate conditions and subconditions to the execution of methods. Here another example, and when you compile this code, this source code with our NOPL compiler, you translate this source code into C++ code, and then you integrate this C++ code with other C++ code, with libraries, and then these libraries are called directly from NOPL methods, and you can, with general C++ compiler, generate executable code. Our experiments with this language were based on the small size leak. We developed a complete control system for a team of 6 robots that are real robots with 180 millimeters in diameter, with a centralized division system that sends the information about the positions of the robots and the ball to a central computer, and then replies this information to the computer that runs the team. And then this computer sends by wireless communication the commands to each of the robots of a team. In 2020, due to the pandemics, we couldn't execute the real category, so we used the simulator, GR Sim simulator, together with Referee Box, that's a control software, and we developed our software to control these simulated robots. Here is a small video of our system controlling the robots. Let me show you. So the robots control their position, if they are attackants, they are goalies or something like that. Here the 2 teams are controlling, there are 2 teams running, each one controlling 6 robots. So our complete program is written in NOPL, and only the implementation of some methods call the execution of the source code that controls the robots and receive information about the change of the state of the game. So we define FBAs with attributes and methods, then we instantiate these FBAs, and then we write rules in this syntax, calling methods from the FBAs instantiated. The version 1.0 had a big problem, because for every instance you had to write rules, and if 2 instances had the same rule, you have to duplicate the rule, only changing the instance of the robot that is being controlled. So in NOPL 1.2 we included the rules inside of the FPAs. We call it FPA rule, that every instance of this FPA has a version of these rules. So we put our rules inside the FPAs, and we can instance 6 robots, for example, and each of the 6 robots would have all the rules with this word here, robot, that's the same name of the FPA. The system automatically creates the rules for each instance. Here is the class diagram of our software developed in C++ that we previously developed for our team of 6 robots. And here, an example of the source code. There are lots of ifs, switch cases, and lots of situations that should be evaluated in this software. So, with NOPL, we were able to build the complete system to control all 6 robots with only 74 NOPL rules, plus methods to interface with the simulator. And here is the source code of the NOPL 1.2 that has 72 rules with this form factor, and the robots with the attributes, the ball, and so on. Here are some results. We compare using lines of code and tokens. So, with NOPL 1.0, our source code had 8,500 lines around. With NOPL 1.2, it came down to 3,300 lines. With NOPL 1.0, we have over 40,000 lines, 40,000 tokens, and NOPL 1.2 only 19,200 tokens. That is more or less the same size of the C++ source code with 3,600 lines and 24,000 tokens. So we can, with the same order of magnitude of the source code, develop a system that behaves exactly like the original source code in C++. As conclusions, we can say that the implementation of FBA rules allowed to create application in NOPL 1.2 with 61% fewer lines of code and 52% less tokens when comparing to NOPL 1.0. And this allows for development of applications in NOPL by allowing the source code to be more concise, pragmatic, and structured. By comparing NOPL 1.2 source code to the solution developed in OOP with C++, the code size was comparable. And we think that the great advantage of explicitly developing source code in NOPL is because you put the rules very clearly in the source code. All decision making is well organized and easily understandable by any developer. As future developments, we are already developing NOPL 2.0 that is a newer version with code generation in C++ with namespace for speed of execution. And we are also developing control software for other leagues of robots for Robocop. We are intending to develop this program by several programmers to obtain qualitative and quantitative data about the productivity and maintainability of both NOPL and C++ source code. We think that by introducing NOPL, we will allow the developers to develop a very well-organized source code much closer to the declarative paradigm. Here are some pictures from our team of robots and people from Latin American robotics competition. And we work at the LASER, that's the Advanced Laboratory for Embedded System and Robotics. So now I would like to answer some questions.